Carvings chiseled into a large stone pillar in Turkey nearly 13,000 years ago may be the world's oldest sun and moon calendar, a new study suggests, and the calendar may have been carved to mark a catastrophic comet strike. The news of this study recently circulated the media, so we will take a closer look at these findings. But before we do that, please subscribe to my channel as we are nearing the 500 subscribers count, and it would be awesome if you joined our group of history and prehistory enthusiasts. Alright, let's go. Martin Sweatman, a scientist at the University of Edinburgh, claims that markings on the so-called Vulture Stone at Göbekli Tepe represent a calendar and document a significant astronomical event, a comet impact around 10,850 BC that had a profound effect on Earth, which makes the ancient pillar a type of memorial. Sweatman recently published the results of his research into the symbols at Göbekli Tepe. He argues that each V-shaped symbol carved onto Pillar 43 in Building D could signify a single day, with the entire calendar encompassing 12 lunar months, in addition to 11 extra days. The final V on the pillar is represented by a V worn around the neck of a bird-like beast, resembling a vulture, and thought to represent the summer solstice constellation at the time it was carved. Other nearby statues, potentially depicting deities, also bear similar markings. Pillar 43 in Building D is one of the most spectacularly adorned pillars at Göbekli Tepe. It is decorated on 3 of its sides. The west-facing broad side is the most lavishly decorated. It features animal depictions and abstract motifs. In the upper part of the composition, there are 3 bucket-shaped objects, each of which is accompanied by a wild animal, below which there is a frieze with geometric motifs and a sitting vulture with a sphere balanced on its wing. Another bird, possibly an ibis, is depicted together with a small snake. Next to these figures are 2 H symbols, one of which is rotated 90 degrees. The narrative is completed on the adjoining shaft by depictions of, among others, a fox, a scorpion, and the head of a bird. Most notable is the figure of a headless male with an erection. Scientists like Sweatman think that a cluster of comet shards may have smashed into Earth's surface 13,000 years ago, and the drawings, which were likely made during that time, were a way to record the comet strike. This event, however, has been a point of contention among scholars. Analyzing geological data from the areas where Sweatman and his team think it may have hit, namely North America and Greenland, they found high levels of platinum, evidence of extremely high temperatures that could have melted materials at the site, and nanodiamonds, which scientists know can be created from explosions and can exist inside comets. However, supposed traces of this event can be found in other parts of the world too. One such example can be the work of archaeologist Andrew Moore from the Rochester Institute of Technology and his team. They analyzed sediment layers from Neolithic site Abu Huraira, which was excavated in the 1970s before being submerged under Lake Assad by the construction of the Euphrates Dam. Abu Huraira is well known as the site with the earliest evidence of a shift from hunter-gathering to farming. In the sediment layer from the beginning of the Younger Dryas period, they found shock-fractured quartz grains, which they say are consistent with impact and evidence of a massive firestorm. The Younger Dryas period that occurred about 12,900 to 11,700 years ago was a rather sudden, severe and lengthy interruption to the warming of Earth's climate. Detailed analysis showed some quartz grains in this layer are similar to those found in nuclear explosions and the meteor crater created by the Barringer meteorite impact about 50,000 years ago. They also found tiny diamonds and small balls of silica and iron in the Younger Dryas boundary layer sediment. Tiny spherules, called melt glass, make up about 1.6% of the sediment and were discovered on tools, bones and clay walls, suggesting the impact, really disrupted life in the village. Some of the substances found could only have formed under higher temperature or pressure conditions than any human technology could produce at the time. Notably, the team didn't find similar material in thousands of years of human-deposited sediment above the Younger Dryas boundary layer. The comet's strike is thought to have set off major climate change in the northern hemisphere. It changed from more humid conditions that were forested and with diverse sources of food for hunter-gatherers to drier, cooler conditions, when they could no longer subsist only as hunter-gatherers. This cooling period possibly caused groups of people to band together to cultivate crops, leading to the development of agriculture, which in turn led to huge leaps in technological innovations and societal developments. According to Sweatman, the impact of the comet's strike was enough to cause a cultural shift within Göbekli Tepe and may have even resulted in the formation of a new cult or religion. It needs to be noted that the Younger Dryas impact hypothesis has faced several challenges from the scientific community. One of the arguments against the hypothesis is the absence of a definitive impact crater from the proposed event. While proponents have pointed to possible impact structures like the Hiawatha Glacier in Greenland, these remain speculative and not universally accepted as being linked to the Younger Dryas event. To be fair though, if it was an airburst rather than a direct impact, there wouldn't be a crater. Proponents of the impact hypothesis have cited the presence of materials like nanodiamonds, iridium, and microspherules as evidence of an extraterrestrial impact. However, subsequent studies have found these materials inconsistently across different sites. Some studies have failed to replicate these findings or have offered alternative explanations for their presence, such as wildfires or geological processes unrelated to an impact. The black mud layers, a thin, dark sedimentary layer found in various locations across North America, were initially thought to be linked to the impact. Critics argue that these layers do not consistently contain the proposed impact markers and that similar layers can be formed through non-catastrophic processes, such as changes in local hydrology or organic matter deposition. While the Younger Dryas did have significant ecological effects, critics argue that the evidence for a sudden, impact-related extinction event is weak. The extinction of megafauna in North America, for instance, is believed by many researchers to have been caused by a combination of human overhunting and climate change, rather than a single catastrophic impact. The Younger Dryas can be explained by natural climate variability, such as disruptions in ocean circulation, particularly the shutdown of the Atlantic meridional overturning circulation. This theory is supported by evidence of large meltwater pulses into the North Atlantic, which could have caused the abrupt cooling without the need for an impact event. The timing of the Younger Dryas onset does not align perfectly with the proposed impact event in some records. This mismatch in dating calls into question whether the hypothesized impact could have been the cause of the cooling event. These arguments suggest that while the Younger Dryas impact hypothesis remains intriguing, it has not been universally accepted due to significant challenges in the evidence and alternative explanations that better fit the data. This also means that Sweatman's interpretation of the Göbekli Tepe carvings, although fascinating, needs to be treated with a pinch of salt.